Welcome back to my channel. Myself Vikas Arich. I am currently doing my engineering in SUCE College. Today's topic is about the applications of inverse transform of logarithmic from the subject mathematics. Applications of inverse transform of logarithmic in triple E. Introduction to applications of inverse transform of logarithmic in triple E. The inverse transform of a logarithmic function is a powerful tool used in electrical and electronics engineering. It is commonly applied in signaling process, control systems, and communication systems. Understanding its applications can help in solving complex engineering problems efficiently. Signal processing. In signal processing, the inverse transform of a logarithmic function is used to analyze and process signals in the frequency domain. It helps in converting signals from the frequency domain back to the time domain for further analysis and processing. This application is crucial in designing filters, modulators, and demodulators in communication systems. Control systems. Control systems use the inverse transform of logarithmic functions to design controllers that regulate the behavior of dynamic systems. By transforming system models from the frequency domain to the time domain, engineers can analyze stability and perform characteristics. This application is essential in industries such as aerospace, automotive, and robotics for ensuring system stability and performance. Communication systems. In communication system, the inverse transform of logarithmic functions is applied in signal modulation and demodulation techniques. It helps in converting modulated signals from the frequency domain to the time domain for transmission over channels. This application is fundamental in wireless communication, satellite communication, and data transmission systems. Filter design. Filter design in Triple E often utilizes the inverse transform of logarithmic functions to design and optimize filters for various applications. Engineers can analyze filter responses in the frequency domain using inverse transforms to achieve desired filtering characteristics. This application is crucial in designing low pass, high pass, band pass, and band stop filters for different signal processing tasks. System identification. The inverse transform of logarithmic functions is employed in system identification to estimate the parameters of dynamic systems from input-output data. By transforming system modules to the time domain, engineers can identify system dynamics and optimize control strategies. This application is essential in modeling and controlling complex systems in industries like power systems, manufacturing, and power control. Power systems analysis. Power system analysis utilizes the inverse transform of logarithmic functions to study the behavior of electrical networks and components. Engineers can analyze power system stability, fault conditions, and transient responses by transforming frequency domain models to the time domain. This application is critical in ensuring reliable and efficient operation of power grids, generators, and distribution systems. Circuit design. In circuit design, the inverse transform of logarithmic functions is used to analyze and optimize circuit performance in the time domain. Engineers can evaluate circuit responses to input signals, noise, and disturbance by transforming frequency domain models. This application is essential in designing analog and digital circuits for applications in electronics, telecommunications, and instrumentation. Digital signal processing. Digital signal processing employs the inverse transform of logarithmic functions to process and analyze digital signals in the time domain. It helps in implementing algorithms for filtering, modulation, demodulation, and spectral analysis of digital signals. This application is crucial in designing digital communication systems, audio processing, image processing, and sensor networks. Feedback control. Feedback control system utilize the inverse transform of logarithmic functions to design controllers that stabilize and regulate systems behavior. By transforming system models to the time domain, engineers can analyze feedback loops, closed loops, responses, and stability margins. This application is fundamental in designing PID controls, adaptive control system, and robust control system strategies for various applications. Antenna design. Antenna design in Triple E uses the inverse transform of logarithmic functions to analyze, optimize, and tune antenna parameters for wireless communication. Engineers can study antenna radiation patterns, impedance matching, and bandwidth characteristics by transforming frequency domain models. This application is essential in designing antennas for applications in cellular networks, satellite communication, image processing. Image processing applications employ the inverse transform of logarithmic functions to analyze, enhance, and compress digital images. By transforming image data from the frequency domain to the spatial domain, engineers can apply filters, transformations, and compression techniques. This application is crucial in medical imaging, satellite imaging, security systems, and multimedia applications. Wireless networks. Wireless networks utilize the inverse transform of logarithmic functions to design, optimize, and analyze network protocols and performance. Engineers can study channel characteristics, signal propagation, and interference effects by transforming frequency domain models. This application is fundamental in designing wireless communication protocols, network planning, and resource allocation for efficient data transmission. Robotic and automation. Robotics and automation systems use the inverse transform of logarithmic functions to model, analyze, and control robotic manipulators and automated processes. By transforming systems dynamics to the time domain, engineers can design motor control algorithms, trajectory planning, and sensor fusion techniques. This application is essential in industrial automation, autonomous vehicles, robotic surgery, and smart manufacturing systems. Industrial control. Industrial control applications employ the inverse transform of logarithmic functions to design and optimize control strategies for industrial processes. Engineers can analyze process dynamics, disturbance, and control loops by transforming frequency domain models to the time domain. This application is critical in industries such as chemical processing, oil and gas, power generation, and water treatment for ensuring operational efficiency and safety. Audio engineering. Audio engineering utilizes the inverse transform of logarithmic functions to process, analyze, and synthesize audio signals in the time domain. Engineers can design audio filters, equalizers, reverberation effects, and compression techniques by transforming frequency domain models. This application is crucial in music production, sound reinforcement, acoustic design, and speech recognition system. Renewable energy systems. Renewable energy systems use the inverse transform of logarithm functions to analyze, optimize, and control energy generation and storage systems. Engineers can study renewable energy sources, power converters, grid integration, and energy management by transforming frequency domain models. Smart grids. Smart grid applications employs the inverse transform of logarithmic functions to monitor, control, and optimize electricity distribution and consumption in smart grid systems. IoT and sensor networks. IoT and sensor networks use the inverse transform of logarithmic functions to process, analyze, and transmit sensor data for real-time monitoring and control applications. Conclusion. The applications of the inverse transform of logarithmic functions in triple E are diverse and essential for solving complex engineering problems. Understanding how to apply this mathematical tool in signal process control systems, communication systems, and various other domains is crucial for engineering. By leveraging the power of the inverse transform of logarithmic functions, engineers and can design innovative solutions, optimize system performance, and advance technology. Thank you for watching my video. Please like, share, and subscribe.